Hi, I'm Sebastian Yang. I'm the tech team lead in this research project. When was the last time you stand up and exercise? A few hours ago? A few days ago? Or is it even a few weeks ago? As people spend more and more time sitting in front of a computer, especially during a pandemic, we really need more evidence-based practices that promotes both physical activity as well as cognitive engagement. And that is what we are trying to do here. In this project, we recreated a commercially available virtual reality game called Beat Saber. We did it in Unity from scratch. In this game, a string of blocks will be flying to the player's direction, and the player will have to slice the block with the correct saber at the correct timing in the correct direction. And that could either be left, right, up, down, or diagonal. They also have to dodge obstacles like the one flying right now. In our recreation, we are not only able to read the beat map from a normal Beat Saber game, but we are also able to add a lot of additional features, such as tutorials for new players and practice trials to get the player familiar with the game. We also have auditory and visual feedback to reinforce the player's behavior, and multiple songs for participants to play. Moreover, we have a score system to let the participants know how well they're doing. In addition to that, we developed a UI that is only visible to the researcher and not visible to the participants in VR. This will allow the researchers to change the different conditions that we want to manipulate for our research study. The game also automatically saves data about the player's accuracy. This is much more efficient and less error-prone than manually enter the data. We use C# to code the game and use GitHub for our version control. We deployed an agile method to conduct weekly sprints, and we use Kanban to track our progress across each week. Now my friend Kalpa will talk more about our research conditions.
Hi, I'm Kalpa Anjar. I'm a senior studying computer science with a minor in game design. This study is a follow-up replication experiment of a prior study conducted with preschool-aged children that studied the effects of physically active and cognitively demanding video games on cognition that we carried out at the children's school. In that study, we systematically modified the levels of exercise and cognitive engagement. It was found that combined exercise and cognitive training improved performance on cognitive assessments. The goal of this study is the making portion of an experimental study with 18 to 22-year-old adults in virtual reality to examine whether the findings of enhanced cognition generalize across virtual contexts and development. So the first condition is the exercise condition. This is when the participant will be standing and they must slice each block to the beat in the indicated direction, or the arrow on the block. Participants will also dodge obstacles. And across conditions, participants will play the tutorial and practice songs in whatever condition they're randomly assigned to. And then they will play 10 songs. In this condition, the cognitive demand is less, but the physical activity is higher. Next, we have the combined condition. In this condition, there's a rule switch, so that for every other song, participants will hit the blocks in the opposite direction of the arrow on that block, but they're still trying to hit it to the beat. We also ensured that auditory and visual feedback is appropriate in this condition. In this condition, the cognitive demands and physical activity are higher. Next, we have the cognitive condition. This is identical to the combined condition, except that the participants will be sitting in an adjustable chair, which will control for energy expenditure reaching. This condition also has disabled flying obstacles because participants cannot avoid them while sitting. And in this condition, we have increased cognitive demand and decreased physical activity. Finally, we have the control condition. This is almost identical to the exercise condition, except there's no rule switch between songs, and participants will sit rather than stand. So in this condition, there's decreased cognitive demand and decreased physical activity. This completes the 2x2 design.
Hello, I'm Matthew Komar, and I'm a sophomore at a student-defined and immersive computing. I'm going to show you our conditions now.
Now to the right, left, right, right, left, right, left, left, right, right, left, right. Now to the right, left, right,
One of the cognitive outcome measures we used was the attention task, which is a visual search task containing 24 distractor objects and a target, which may or may not be present. The 24 distractor objects include a red square and a blue circle, whereas the target is a red circle. There are 24 total trials, with 16 having the target present and 8 with the target not present. If the participant sees the target, they press one button, and if they don't see the target, they press a different button. Performance on this task has been found to be related to executive function and attentional abilities, and is considered developmentally appropriate across all age groups.
My name is Adrian Mester. I am a senior studying computer science and music technology. The Stroop task is a neuropsychological test that measures selective attention and cognitive flexibility. It is used frequently in screening for brain damage, and performance has been linked to educational outcomes. Color words are presented in colors that either match or conflict with the semantic meaning of the words, and participants are instructed to press one of 4 RGBY buttons on the keyboard that corresponds to the font color of the stimulus word. For example, R for red, B for blue. A practice session precedes 5 blocks of 48 trials each. These 48 trials consist of 32 congruent and 16 incongruent, randomly assembled and then presented to the participant. The primary measure is mean reaction time for the incongruent trials. Along with these tasks are our covariates, which include the PACES questionnaire and VR exposure questionnaire. PACES is a 16-item questionnaire that assesses a participant's position towards physical activity. The VR questionnaire goes through an increasing series of questions that determine the degree to which the participant has experience with video games. After responding yes or no, the participant indicates how often they interact with the media. A frequency of gameplay variable was created by selecting the highest score from this questionnaire with a range of 0 to 5. A score of 5 indicates the participant interacts with the media a few times a week, while a score of 0 indicates the participant did not play any type of digital games. I would now like to hand off to my teammate George to talk about future directions for this study.
Hello, I'm George Whitfield. I'm a junior in electrical and computer engineering here at CMU, and I'm going to present about the future directions of the VR study. Right now, we are collecting data using our own Unity app that we made, but participants actually need to come to the Cognitive Development Lab on CMU's campus to do the data collection itself. And that's not exactly what we want. In the future, we would hope to collect data remotely. And the way we can do that is by taking our existing in-person app and just putting it on the internet. And there's a couple of things we have to work out for that to work, but in general, that can be achieved by creating something called a web app. And what a web app is just a piece of software that lives on the internet. It can receive requests from someone else on the internet, and it can send out requests. Things like websites and apps, social media networking apps, those are all web apps themselves. So anything that's on the internet, you can just kind of think of as a web app. And there's 3 big challenges that I researched about related to putting this stuff on a web app. Well, the first one is the data has to be secure. Since we're collecting data about children, you can't just put it in any old database or use any old security protocol. It needs to be extra secure because children's data, there's more strict regulations about that compared to adult data. And then the second thing is the data collection itself, you actually need to redesign a little bit what we're doing, because in person, things like heart rate, we can have the same researcher do the exact same data collection for every single participant. But for a remote study, people would have to collect that data themselves. So that requires a little bit of a redesign in the app itself, so we can reduce any error for people collecting like their own heart rate, for example. And then the last thing is just we have to refactor the code. So there is going to be a little bit of manpower needed to take the code that is for the in-person data collection and put it online. But overall, I think it should be straightforward. And we have a lot of talented people on our team. So yeah, that's about it.
Hi, I'm Adrian Ma, and I'm going to expand on our plans for the future. Going forward, we plan to enhance the user experiences of our participants by improving the aesthetics and environment of our game and by adding more forms of visual feedback. Here's a quick comparison of what we have now and what we hope to achieve. We also plan to implement machine learning into our game so that songs can adjust to individual playing capabilities, as well as tutorials for each of the conditions so that our participants can have an easier time learning the experimental task. Finally, we would like to thank the Army that made this possible, the research assistants in the lab, our advisors Cassie Eng, Dr. Anna Fisher, and Dr. Eric Thiessen, and the Institute of Education Sciences and the Undergraduate Research Office's SURF, SURGE, and SUR opportunities for funding this research.